Welcome to this demo session where we are going to look at how you can deploy Enterprise Server in a performance and availability cluster so it can scale by adding additional resources as your business demands vary. I'm Graham Owen and I work in the Mainframe Solutions product management team, focusing on our mainframe application deployment solutions, Enterprise Server and Enterprise Server for .NET. I'm joined in this session by Alan Staves, who will be demonstrating some of the concepts and approaches that will be outlined here. In this session, we will focus on scalability. This is a common business challenge for all customer-facing applications where usage patterns are unpredictable, including applications that have been rehosted from the mainframe. In this session, we will focus on how this challenge can be addressed using a performance and availability cluster when running your applications in Enterprise Server. To help you understand how this works in practice, Alan Staves, one of our principal software engineers, will demonstrate how Bank Demo running in Enterprise Server can scale up using Kubernetes based on increasing demand. We will close out this session by considering how being able to scale out helps you when deploying larger workloads. Scalability, along with availability, is one of the mainframe's most valued attributes. Mainframe systems are recognized throughout the industry for their ability to deliver a consistent response for critical applications. This is often achieved by using Workload Manager to prioritize the available resources, using capacity on demand to add processing capacity, or a combination of both. For applications that originated on the mainframe, these characteristics are important for the service delivery and have significantly influenced the operational processes. This means that the target platform for any rehost needs to offer a similar ability to scale on demand. Flexible scaling is one of the attributes that is driving adoption of the cloud, whether it's private, public or hybrid. But while adopting the flexibility that the cloud vendors delivers, it is noticeable that a growing numbers of users are adopting a hybrid cloud approach, mixing private and public cloud infrastructure or a multi-cloud approach with services deployed across different cloud vendors. The normalization of the hybrid and multi-cloud approach is driving the adoption of containerization, as this supports interoperability between different cloud infrastructures. So in considering the rehost of a business-critical mainframe application, you'll be looking for a scalable solution that can be flexibly deployed, with the most likely target platform being a private or public cloud. In version 5 of our enterprise solution, we introduced some important new technologies that simplify the deployment of the cloud to the cloud. Alan will show some of this in more detail in the demo. The performance and availability cluster gives you the ability to define and operate a group of enterprise server regions as a single entity, defined and managed through a scale-out repository. This eliminates single points of failure and is the basis for our ability to scale. This can all be easily managed through the Enterprise Server Common Web Administration GUI, with any vSAN data transparently rehosted using the Micro Focus database file handler to SQL Server, DB2 or Postgres. In practice, this means that we can easily configure the system to scale up on demand. In the example on screen, we start with 3 active regions in the performance and availability cluster, then add a 4th. The scale-out repository is used to share the artifacts required to keep the regions synchronized. Adding an additional region can be achieved using any of the widely adopted server virtualization technologies in any of the public clouds, or as Alan will now demonstrate, by using Docker containers managed by Kubernetes.
Thanks, Graham. We are using a Kubernetes cluster here to run our favorite Bank Demo application. Much of what I'm going to show you can be achieved using VMs rather than Kubernetes, but Kubernetes is what I use today. Kubernetes runs containers in pods, and our application pod is configured as part of a performance and availability cluster, or PAC. This allows the application capacity to be scaled up and down dynamically. Here, looking at the Kubernetes dashboard, we can see our pod is running as a stateful set. And we've configured the stateful set to automatically scale out. That is, add extra pods to the set when additional load is applied to the application. So we can use Rumba to attach to the application. Let's run our transaction and log in. And one of the features of the application is that it can calculate a loan for us. So let's just take a look at that now. So we can try £1,000 or $1,000, whatever unit you want, an interest rate of 5% and over 36 months. And that would cost us £29.97 apparently. So that didn't really tax the application. So let's apply some proper load. For that, we can use another Micro Focus product called LoadRunner. In this tool, we've already created a scenario that drives that loan calculation portion, the bank demo that we just looked at, with an increasing number of virtual users. So I'll kick that scenario off now. Okay, so that should be up and running in a second. Yep, so there we go, we're off and going. So the number of virtual users will gradually ramp up to 50, and it does that, the load on the actual application will increase. It will take a few minutes, but Kubernetes has been configured to monitor certain metrics which are published by our enterprise server. And when it detects that the load has increased beyond a certain acceptable threshold, Kubernetes will provision an additional member into the pack for us. So our new Enterprise Server Common Web Administration, or ESWA tool, can be configured to automatically monitor what's been happening in Kubernetes. So let's take a look at that now. So if we log into ESWA, we can see here that we have our directory server. Just refresh that list. We can see we've got one member. There's only one directory server there. And if we expand that, can't expand that, we can see we actually have a running bank demo instance here. There we go. So that's our running bank demo. So this was automatically detected from Kubernetes. We have a nice little sub-Kubernetes icon there that shows that was discovered from Kubernetes. Now, ESWA can also be configured to show information about scale-out repositories, or SORs. And this has one SOR defined in it called MyPack or Bank Demo. So these repositories are a way that all the members of the performance and availability cluster share information so that they operate as though they're a single enterprise server instance. By that I mean sharing the load across the entire pack. So if we expand that, we'll see that we have one instance, and that's the same instance that we just saw up here. So those two things are the same. So, oh, and there we can see we've just got an extra instance has now been added. So we've obviously moved past that threshold of load, and we've had an extra instance added to the SOR. So this SOR list here that's effectively the list of members of the pack. So we just saw that grow there. So if we refresh the list of directory servers, we should find that we've got an extra one there now as well. So it is worth mentioning that the pack is using the Micro Focus database file handler. So we've named this pod MFDBFH to indicate that, and that allows the sharing of data files such as VSAM between the members of the pack in a way that performs well when the number of members of the pack scales out. If you don't do that, if you were to just use normal file share, then it wouldn't scale so well. So we've got this new technology of MFDBFH that allows the scaling to be much improved. So I think that was all I wanted to show. So thank you. Back to Graham. Oh, there you go. We've got a third one now. Back to Graham.
As you have seen, using the performance and availability cluster, the processing capacity available to your enterprise server regions can be dynamically scaled up and down to meet the demands of the business. With the performance and availability cluster, you can also spread the workload for larger applications across multiple servers, removing the capacity constraints associated with a single server deployment and the single point of failure. If you would like some more examples on the use of containerization, we have provided links to 2 Bright Talk sessions from last year where we covered deployment and scalability. Of course, Kubernetes is not the only way this scaling can be achieved using the performance and availability cluster. VMware, Hyper-V and all the major cloud vendors can be used to quickly deploy additional pre-configured virtual machines on demand. Thank you for watching this demo. We hope that you found it informative and useful.